Have you ever pondered over the origins of our universe, the beginning of everything we know and see? It's a question that has tickled the minds of philosophers, scientists, and thinkers throughout history. The cosmos, with its vastness and complexity, has always been a source of profound curiosity and awe. It's a mystery that has led us on a relentless quest for answers, a journey that continues to this day. Human beings, in their inexhaustible thirst for knowledge, have sought to understand the very fabric of existence itself. This quest has led us to the depths of the oceans, to the highest peaks, and beyond our world, into the great expanse of the cosmos. And in this relentless pursuit, we have unearthed a myriad of theories, each more fascinating than the last. Among these theories, one stands out as the most accepted explanation for the origin of the universe: the Big Bang Theory. It's a concept that has been around for over a century, yet continues to captivate us with its profound implications. This theory suggests that our universe, in all its vastness and complexity, originated from a singularity, a point of infinite density and temperature. The Big Bang Theory isn't just about the birth of the universe, but it's also a story of transformation, of matter and energy, evolving over billions of years into the galaxies, stars, and planets we see today. It's a cosmic narrative that weaves together the laws of physics, the nature of time and space, and the fundamental forces that shape our reality. But like any good theory, it leaves us with more questions than answers. What caused the Big Bang? What was there before it? And what lies beyond the observable universe? These are questions that continue to intrigue us, driving us to push the boundaries of our knowledge and understanding. So let's take a moment to marvel at the mystery and grandeur of our existence. Let's delve into the enigma that is the cosmos, explore the fascinating theories that seek to unravel its secrets, and ponder the profound questions it poses. Let's journey back in time to the very beginning, to the moment of the Big Bang. Picture this: all matter, all energy, everything that exists, compressed into a tiny, incredibly dense point. This was the state of the universe around 14 billion years ago, just before the Big Bang. Imagine the entirety of existence, all the galaxies, all the stars, all the planets, every single atom, all squished into a pinpoint smaller than the period at the end of this sentence. Then, in an instant, the Big Bang happened. It wasn't an explosion in the traditional sense, but rather an expansion of space itself. All that matter and energy, once compressed, began to expand and cool down. The universe as we know it was born. This initial singularity, the single incredibly dense point, was so hot that even atoms couldn't survive. It was a soup of subatomic particles, a hot, dense state of quarks and leptons. But as the universe expanded, it cooled down, and these particles began to combine. Quarks came together to form protons and neutrons, the building blocks of atoms. In the first few moments after the Big Bang, the universe was a boiling, turbulent sea of particles and energy. It was a place of extreme temperatures and pressures, so intense that our current understanding of physics can hardly describe it. As the universe continued to cool, protons and neutrons began to combine to form the nuclei of simple elements. Hydrogen, helium, and traces of lithium were the first to form. It took hundreds of thousands of years for the universe to cool down enough for these nuclei to capture electrons, forming the first atoms. The timeline of the universe's birth, from the moment of the Big Bang to the formation of the first atoms, spans a mind-bogglingly short fraction of a second. But in that brief moment, the foundations for everything we see around us today were laid. The galaxies, the stars, the planets, even life itself, all originated from that tiny, incredibly dense point. Within a fraction of a second, our universe was born. The universe was a hot, dense sea of particles and energy, expanding rapidly. Imagine it like a giant cosmic soup, boiling with activity. In this early stage, the universe was so hot and so dense that particles of matter and antimatter were continuously created and destroyed in collisions. However, as the universe expanded, it also cooled. This cooling slowed down the particle-antiparticle annihilation, allowing matter to gain the upper hand. As the temperature continued to drop, protons and neutrons began to come together, forming atomic nuclei in a process known as nucleosynthesis. This process occurred within the first 3 minutes of the universe's existence, and it resulted in the creation of light atomic nuclei, hydrogen, helium, and traces of lithium. But even after this, the universe was still too hot for atoms to fully form. Electrons whizzed around unbound, colliding with photons and scattering light in all directions. The universe at this stage was like a dense fog, opaque and filled with energy. However, the universe kept growing and cooling. Finally, around 370,000 years after the Big Bang, the universe had cooled enough for electrons to combine with nuclei, forming neutral atoms. This era is known as the era of recombination, and it marked the birth of the first atoms. With the formation of these atoms, the universe became transparent to light. The photons that had been scattering off electrons could now travel freely across the cosmos. This light, the afterglow of the Big Bang, is what we see today as the cosmic microwave background radiation. It's like a snapshot of the universe at that time, a baby picture of the cosmos. This radiation is incredibly uniform, with tiny fluctuations that reflect the seeds of future structure in the universe. These minute differences in density and temperature would go on to form the vast cosmic web of galaxies and clusters we see today. As the universe cooled and expanded, the stage was set for the formation of structure. In this vast, expanding universe, matter began to coalesce, forming the first galaxies and stars. In the aftermath of the Big Bang, the universe was a hot, dense sea of particles. As it cooled and expanded, these particles began to come together, forming atoms, the building blocks of matter. Gravity, that ever-present force, played a pivotal role in this process. It pulled these atoms together, creating dense pockets of matter amidst vast, empty spaces. These pockets of matter became the nurseries of the first stars. Gravity pulled more and more matter into these pockets, compressing it and heating it up. Eventually, the pressure and heat became so intense that nuclear fusion ignited, giving birth to the first stars. These stars weren't like the ones we see in our night sky today. They were massive, hot, and short-lived, burning through their fuel at an incredible rate. When these first-generation stars exhausted their fuel, they didn't go quietly. Instead, they exploded in spectacular supernovae, scattering their enriched guts across the cosmos. This stellar debris, containing heavier elements like carbon, oxygen, and iron, became the raw material for the next generation of stars and, eventually, planets. Meanwhile, gravity was also at work on a larger scale, pulling these early stars together into clusters, which eventually grew into galaxies. Our own Milky Way galaxy, for instance, is a vast, spiraling collection of hundreds of billions of stars, gas, dust, and mysterious dark matter. Within these galaxies, new stars continued to form, and around some of these stars, planets began to take shape. In our own solar system about 4.5 billion years ago, a swirling cloud of dust and gas collapsed under its own gravity to form our Sun and the surrounding planets, including Earth. Over billions of years, the universe evolved into the cosmic panorama we see today. The story of galaxies and stars is the story of the universe itself, a tale of creation and destruction, of chaos and order, and of the profound interplay between matter, energy, and gravity. The Big Bang Theory has stood the test of time, providing answers to some of our biggest questions. Today, this theory is more than just a cornerstone of modern cosmology. It's a testament to human curiosity and our relentless pursuit of understanding the world around us. The Big Bang Theory has undergone countless refinements since its inception, each one adding a new layer of understanding to our cosmic story. In this grand narrative of everything, we've learned that our universe is not only expanding, but its expansion is accelerating, a phenomenon that couldn't be explained by the traditional laws of physics. This led to the groundbreaking discovery of dark energy, a mysterious force driving this acceleration. Dark energy, along with dark matter, is a key piece of the cosmic puzzle. Together, they account for approximately 95% of the universe. Yes, you heard it right, 95%. What we see, The stars, galaxies, planets, and everything else is just the remaining 5%. This is a humbling realization and a testament to how much we still have to learn. The Big Bang Theory also gave birth to the concept of cosmic inflation. The idea that the universe underwent an extremely rapid expansion in the moments just after the Big Bang. This concept has helped us understand the large-scale structure of the universe and why it appears to be the same in all directions. But the Big Bang Theory is not just about explaining the past, it's also a roadmap to the future. It gives us a glimpse into how the universe might evolve, how galaxies and stars will change, and what our cosmic destiny might be. The Big Bang Theory continues to evolve, just like our universe. It's a living testament to our thirst for knowledge, our desire to understand where we came from and where we are going. And as we continue to explore and discover, the Big Bang Theory will undoubtedly remain our guiding light. The Big Bang Theory continues to guide our understanding of the universe's past, present, and future. Yet the Big Bang Theory doesn't have all the answers. There are still many mysteries to unravel. Indeed, as we delve deeper into the cosmos, we are left with more questions than answers. One of the most pressing questions that confound scientists is, what caused the Big Bang in the first place? While the Big Bang Theory excellently explains the aftermath of this cosmic explosion, it is silent on what triggered this event. Was it a quantum fluctuation in a vacuum? Or perhaps the collapse of a previous universe? As of now, these are purely speculative and remain a topic for future exploration. Next, we grapple with the enigmatic substances known as dark matter and dark energy. These invisible entities, despite making up around 95% of the universe, remain elusive to our understanding. Dark matter, with its gravity, helps galaxies to form and hold together. On the other hand, dark energy seems to be pushing galaxies apart, making the universe expand at an accelerating rate. Yet their exact nature is still a mystery. Identifying what these dark substances are made of is one of the biggest challenges for current and future scientists. Lastly, we ponder the ultimate fate of the universe. Will it keep expanding forever, leading to a big freeze, where stars burn out and everything drifts apart? Or will it eventually start contracting, leading to a big crunch, where everything collapses into a single point? Or perhaps the universe will rip itself apart in a big rip. The fate of the universe is tied to the nature of dark energy, and as we've mentioned, that's still an enigma. Despite these unanswered questions, science doesn't stop. Researchers around the globe are using innovative techniques, sophisticated equipment, and cutting-edge theories to explore these mysteries. The Large Hadron Collider, space telescopes, and quantum computers are just a few tools in their arsenal. The quest for understanding our cosmic origins continues. Each discovery brings us one step closer to unraveling the grand cosmic story of our universe. Our journey from the Big Bang to the present day has been truly awe-inspiring. We've traversed through the enigma of existence, exploring the mystery behind the birth of our universe and the cosmic event that set everything in motion, the Big Bang. We delved into the moments immediately following this monumental explosion, a period of rapid expansion and cooling that led to the creation of the very building blocks of matter. This was a time of extreme conditions, where the very laws of physics as we know them were being written. From there, we embarked on an epical journey through the formation of galaxies and stars. We discovered how, from the primordial soup of particles, the first galaxies took shape, producing the first stars, whose nuclear reactions released the heavier elements necessary for the formation of planets and, eventually, life. We then brought ourselves back to the present day, examining the current understanding of the Big Bang Theory. From the cosmic microwave background radiation, the afterglow of the Big Bang, to the ongoing expansion of the universe, we've painted a picture of a universe that is ever-changing and full of wonder. Lastly, we confronted the unanswered questions in future research. We discussed the mysteries that still elude us, like the nature of dark matter and dark energy, and the possibility of a multiverse. We also looked at the exciting research that promises to shed light on these enigmas, bringing us closer to a complete understanding of our cosmos. It's been a journey of cosmic proportions, a journey that has brought us closer to understanding our place in the universe. We are, after all, children of the cosmos, born from the same stardust that fills our night sky. The universe is a vast, incredible place, and its story is our story. We're all made of stardust, after all. Thanks for watching. Don't forget to like, comment, and follow.